chapter 11, copy 1, page 721. On a single toss of a die. Now, I think we need 3 of these little things out here. Here's one for you, one for you, and one for you.
Oh, thanks.
So, toss. Wait a minute. I better give each of you 2 of them. Two for you, 2 for you, 2 for you. Now, what it says here on page 721 is for problem number 1. On a single toss of a die, what's the probability of obtaining the number 5? So the die has what?
6 sides.
1, 2, 3, 4, 5, 6. And I want to get a 5. What's the probability of obtaining a 5? Okay, how many possibilities are there?
6.
The possibilities are 6. And what is our desired outcome? One of those. Mm-hmm. So the probability is 1/6. The likelihood of getting a 5 is 1 out of 6. Now, each of you has 2 die. So that's equivalent to 6. There's 6 die on the table. Each of you have 2 of them. So if all of you pick your die up, your 2 dice up, I'll show you what I'm talking about here, so I don't confuse anybody. If you pick those 2 up and you drop them on the table, according to mathematical probability, so you got a 5, Celeste?
Me too.
Uh-oh. No. So out of these 6 dies that were dropped, we got 2 5s, and we're only supposed to get 1. No? Do you understand? What we did up here is called mathematical probability. What you just did was real life activity. So, I'm going to write this up here. We dropped 6 die, and we got 2 5s. Do it again. We dropped 6 die.
I got 2 5s.
How many 5s?
2.
You got 2 5s?
I didn't get any.
I didn't get any.
2 more 5s. Do it again.
None.
0 5s. Do it again.
1.
Oh, 2. I got 2 5s.
3 5s. Do it again.
Nothing.
1 5. Do it again. No 5s. Now you see what's happening? If we stayed in here all day and did this 1,000 times,
Come on.
or if we did it 100 times, you see how it starts to the real experience, if you do it 100 times or 1,000 times, gets closer to the mathematical probability. Do you see what's happening? In other words, we had 4, 5, 6, 36, and that would say 6 out of 36, and we had 2, 4, 5, 6, 7, we had 8. See how we're getting closer? And if we would have had, if we would have done this 100 times, we would have come even closer to 6 out of 36, or what would that be? Out of 100, what's 1 divided by 6? Where's my calculator? If we did it out of 100, 1 divided by 6 is 0.16666, so that would be like 17 out of 100, approximately.
When it says a single toss of a die, does that mean 1 die or does that mean?
That means 1. But see, since we have 6 numbers on the die, I had to, instead of dropping 1 die 36 times,
Oh, I see.
we dropped 6 dies 6 times.
Okay.
You could take your die just for fun. Take your die and just take one of them and drop it 6 times. Just drop it. Just count 6 times and see how many 5s you get. Just pick one of them and drop it 6 times.
I got 1 5.
1 5. 1 5 and no 5s.
I think your dice is broken.
It's loaded.
Okay, now see, and that's true. You go, hey, wait a minute. This dice is not a perfectly made. Well, there probably is no such thing as a perfectly made die. But you see what happened when you did it with 1 die 6 times? You got the mathematical probability, didn't you? 1 out of 6. So that's why the guys who run probability games want more and more people playing, because they know that one person might win twice in a row, but there's a whole bunch of other people going to lose a whole bunch of times in a row, because mathematically they're going to come out ahead. Watch this. If each of you pay me $1 to drop a die on the table, and then every time someone gets a 5, I give you a $5 bill. That sounds pretty appetizing, doesn't it?
Mm-hmm.
So for every $6 I collect, I pay out
1 or 5.
a 5.
So you
I just
earn
made
it
$1. So every 12 times, I made $2. Every 120 times, I made $20. Every 1,200 times, I made $200.
But if somebody got a 5 on the first try, then they would get
They would get $5. And but see, I already collected 6, so I give them 5 and keep 1.
Yeah.
And now you see why the people in Las Vegas stay open 24 hours a day.
Yeah.
Because they want people coming in and spending their money. And math always favors the guy running the casino. So just understand that, and if you teach that to your children, I think maybe it'll help them realize that gambling only makes money for the guy who's running the casino. And why do they make such a big deal about the people who win? Because they want everybody else coming in and spending their money. Okay, what about an even number? Now we don't want a 5. We want, I'll go ahead and use purple again. We want an even number. There's 6 possibilities. How many even numbers? 2, 4, 6. So that would be 3 out of 6. You follow that? Or 1/2. Number 4, a number less than 5. So what would be a number less than 5? 4, 3, 2, 1. So that would be what?
4 out of 6.
4 out of 6, or 2 out of 3 times. Number 6. Now what do we have? We don't have dice we're working with. We have a jar with, what's in the jar? A jar with 10 little balls in it, numbered 1 through 10. Number 6, what's the probability of an even numbered ball? How many possibilities are there?
10.
10. How many even numbered?
5.
1, 2, 2, 4, 6, 8, 10. So it's 5/10, or 1/2. Number 8, a ball whose number is less than 10. What would that be? Less than 10 would be anything here or here. So that would be what? Nine tenths. Number 10, a ball that's either less than 5 or odd. Now, watch out for this one. It's either less than 5, so that would be 4, 3, 2, or 1, or it's odd. 1, 3, 5, 7, 9. What's the probability of it being less than 5 or odd?
5.
What's the probability of it being less than 5?
4.
What's the probability of it being odd?
5.
How many times do they overlap?
2.
Here's 1, here's 2. Is that it? So what's this? Okay, so let's count these. Let's change colors. Let's just count these. Here's, this one would work, 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 this one would work. What is that? 7 out of 10? Watch this. Okay, what's 4/10 plus 5/10
9 tenths.
minus 2/10?
7 tenths.
Ah. You see what happens?
Mm-hmm.
And you see, they give a formula, though I keep remembering, you people love formulas. I don't want to think about it. I just want to plug the numbers in and get the answer. Well, they give you a formula in here. Where is it? Back on page. Well, maybe they give it to you in the next one. I don't see it here. Yep, I bet they give it to you in the next one. Well, let's just turn over there and look at it. Just for fun. No. Was it the third one then? Yeah, page 736. Page 736, property number 3. The probability of A or B equals, now let me move this over. The probability of A union B equals the probability of A plus the probability of B minus the probability of A intersect B. See that formula they give you and how it just works out when you're messing with this probability stuff? Okay, let's get back to doing our lesson. We don't really want to spend a lot of time with all this giving me a headache. Let's just do the lesson. Number number 12. Now we're drawing cards out of a deck of cards. How many cards in the deck of cards?
52.
52. So the possibilities are 52. The desired outcome is what? For number 12?
A king of spades.
How many of those are there?
13.
One.
What?
Oh, a king of spades.
There's only
How many are there?
one.
So the probability is 1 out of 52. Number 14, one of the face cards, the cards with pictures on them, which would be Jack, Queen, or King. So possibilities 52. How many face cards are there?
12.
Because there's 4 different kinds and there's 3 of each kind. So that would be 12 out of 52. And you understand, don't you, that they're going to reduce these down? That would be 6 over what, 26? That would be 3 over 13. So you have to reduce the fractions down when you check your answers.
Wait,
Number,
how many face cards are in a suit?
what is the question?
How many face cards are in a suit? 3?
Jack, queen.
Yes, see what it says there for number 14? There's Jack, Queen, or King. They're the ones with faces on them. I mean, nobody seems to notice that, but the face would be a king, a queen, and a jack. Wonder what he looks like. Number 16, a red card or a face card. So I want a red card or a face card. So face cards would be, well, red cards would be what? 26 out of 52?
Yeah.
Face cards would be
Wait.
12 out of 52? Is that right? But where do the red cards and the face cards intersect?
So wouldn't half of the face cards be red?
Let's see.
Yeah.
Red cards, it's a red card and it's a face card. How many of those would there be? What are the red cards? Diamonds. And what? Hearts. And what are the diamond face cards? King, Queen, Jack. And the hearts? King, Queen, Jack. Isn't that where they...
Mm-hmm.
So that means I would have 26 over 52 plus 12 over 52 minus
6.
6 over 52 because of those duplicates. Okay? All right. So what do you think? 4 fair coins are tossed. Well, it looks like I need to pick up the dice and give you some coins. Each of you gets 4 coins. Here's 4 for you. Here's 4. That one's kind of dumpy looking. 4 for you. And here's 4 for you. Isn't this fun, using real stuff to study math?
Mm-hmm.
And I'll get 4 for me. And 4 fair coins are tossed. So that means I just drop all these coins on the table. You can drop your coins on the table. And what's it say for number 18? Draw a tree diagram. So I have 1, 2, 3, 4 coins. I can either get a head or a tail, right?
Yes.
And then for the second one, a head or a tail. A head or a tail. Maybe I should make my tail like this. For the third one, a head or a tail. Head or tail. Head or tail. Head or tail. You see what I'm doing? And then for the fourth one, move this up a little higher. Head or tail. Head or tail. Oops. Head or tail. Head or tail. Head or tail. Head, tail. Head, tail. Head, tail. So you can have head, 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 or head, 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 tail, or head, head, tail, head. You follow me? So what did you get? What did I get? Just line them up and see what you got. Put them in a row. I got head, head, tail, head. Head, head, tail, head. So I got this one. Which one did you get?
I got head, tail, tail, tail.
Head, tail, tail, tail. So you got this one.
I got tail, 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 head.
Tail, 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 head. So you got this one.
And I got tail, 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 head as well.
And so 2 people got that one.
We must have a connection.
Now, do you see why when we draw this tree, if you have 4 little coins in front of you, it helps make sense out of what's going on here with this tree? This is so much fun. You have no idea how much I enjoy this. This is so cool. Because you guys see how this stuff helps bring it to life. So, what am I supposed to do? Show all the possible outcomes? A, I just did that. How many possible outcomes are there? 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16 possible outcomes? Well, how many possibilities here? 2, head or tail, right? How many here?
4.
Head or tail? 2. I mean, every time you drop the coin, you either get a head or a tail.
I see what you mean.
Okay? How many possibilities here?
2.
Head or tail? What about here?
2.
Head or tail? Everybody see that? So now, how do I get 16 out of this row of 2s?
2 times 2 times
2 times 2 is 4, times 2 is 8, times 2 is 16. Isn't that cool stuff? Find the probability, 18b, find the probability that 2 or more heads come up. So I can have 2 or more. Let's see. How many times will I have? Okay, I could have, if it says or more, I could have all heads, couldn't I? You follow me there? So that's 1 out of 16. Plus, I could have 3 heads. Let's see. 1, I had 4. 1, 2, 3. 1. Maybe we should just mark all of these. Let's just come over here and start marking them. 2 or more. So this one would work. This one would work. That's got 3. Head, head, tail, tail. That's got 2. Head, tail, head, head. That one works. Head, tail, head, tail. That one doesn't work.
No, that one would, right? Because it's head, tail, so there's
Head.
2.
See this? This one is head, tail,
Yeah.
head. Oh, it
Oh.
does work then, doesn't it? Wait a minute. Head, tail,
Yeah, so it still has 2
head.
heads.
Yeah, because that's right. Head, tail, head, tail. So
Yeah.
that one does work.
Yeah.
So we can use that one. Then what's the next one? Head, tail, tail, head. That one works, doesn't it?
Yeah.
Head, tail, tail, tail. Nope, that one doesn't work. That's a 0. Then down here, tail, head, head, head. That one works. Tail, head, head, tail. That one works. At least 2 or more. Tail, head, tail, head. That one works. Tail, head, tail, tail. That one doesn't work. Tail, tail, head, head. That one works. Tail, tail, head, tail. That one doesn't work. Tail, 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 head. No, and no. 2 or more. So what's that count up to be? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 out of 16.
Mm-hmm.
All right. Find the probability that exactly 1 head comes up. So you get a head every time. That would be what? So that's B. C would be what? How many times do you get exactly 1 head? I mean,
5.
no, what's it say?
3 times?
4, 5. Oh, yeah, 5.
Oh, exactly 1 head.
Oh.
So
Well,
let's see.
but then that would mean that it has to be the ones that
It
we
has only
had
1 head.
zeros on, because
So let's see.
We needed 2 or more in the last problem.
Yeah.
So now we just need to count those circles, which is 4, 5.
So here's 1 with exactly 1 head. Here's 1 with exactly 1 head. Tail, head. Here's 1 with exactly 1 head. And here's 1 with exactly 1 head. So that would be what?
It's actually no. 4.
4 out of 16. Well, that's 15 out of 16. What happened to the last one? Oh, it's all tails. Doesn't have any heads in it at all. Okay? So C is 4 out of 16. Well, number 20. Find the probability that company A is selected. Do what? Oh, this is for problems 20 through 23. Many companies send packages from one location to another using delivery services such as Airborne, FedEx. Assume that a person can select from 8 delivery services. What's the probability that company A will be selected? How many delivery services are available?
Eight.
How many possibilities? 8, right? And how many desired outcomes? What
One.
did it say?
1.
That A, we have A, B, C, D, E, F, 4, 5, 6, G, and H, right? And which one did it say? That company A would be chosen. So that would be 1/8. Okay? Number 22. Find the probability that company C is not chosen. Anyone but not C. So that would be what? 7/8. The desired outcomes would be 7/8. So 24. The genetic code of an organism is the self-reproducing record of the protein pattern in that organism. This code is formed by 4 kinds of molecules. What are the 4 kinds? A, C, G, T. Is that right? Are those the 4 kinds? A, C, G, T. Draw a tree diagram to find all the possible groupings of 2 molecules. So I want 2 molecules. So here's 1 and here's 2. So I have 4 possibilities here, right? And how many possibilities here? 4 for the second one. Can they be paired up? Yeah, it's possible for both of them to be the same kind. So that means I have A with 1, 2, 3, 4. With A, C, G, T. You follow that? A, C, G, T. A, C, G, T. Since it says draw a tree, we'll do it. A, G, C, T. So now we've drawn our tree. So that's 12A. What's B want to know? I mean 24B. What's 24B? Assume that all the outcomes are equally likely. Find the probability of containing 2 A's. 2 A's. So out of all the possible outcomes, there would be what? 16, 4 times 4, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It'll do 16 if you count them up. And the one I'm looking for is AA, so that would only be 1 out of 16. C, find the probability of obtaining a G and a C in that order. A G and a C, here's a G, here's a C, in that order. There's only one of those, isn't there? Out of 16. And then what's D? Find the probability of containing 2 C molecules in a row. 2 C's in a row. 1 out of 16 for that one too. Okay. You follow this? Number 26. 2 common sources of nicotine are cigarettes and cigars. Suppose that 35% of the adults in America smoke cigarettes and not cigars. So I'm going to draw a picture here of the population of America. And it looks like 35% smoke cigarettes. And then what? 10% smoke cigars. Is that what it says? For 26? Oh no. 10% smoke cigars and cigarettes. Okay, I got my picture right. Find the probability that a randomly selected adult does not smoke cigarettes. What's 35 and 10?
45.
So we want this one over here, right? So what would that be? Out of 100, this would be how much?
65.
55 out of 100. (27 through 30). Use this picture at the bottom of page 722. Find the probability that a person selected at random would be, number 28, would have a high income. How many total possible outcomes based on that picture and that chart? Everybody see that?
Mm-hmm.
Where the 1500 comes from? So how many people have a high income? In that chart, bottom of page 722.
800.
So that means I have 800 over 1500 or 8 over 15. That's the way they'll show it in the answer book when you check it. Has a low income. What would low income be? Out of the total population, how many are low income? Does it say? 240, right? So that's 24 over 150. You can reduce that down. Number 30, a male with a low income. Males with a low income. How many of those are there? I'm still looking at the total population of 1,500. How many are males with a low income? Can you tell by looking at the chart? 40? Okay. In problems 31 to 35, find the probability on a single toss of a pair of die of obtaining a sum of 2. If I drop a pair of die, let's see, I have 1, 2, 3, 4, 5, 6 possibilities for the first number. And 6 possibilities for the second one. So, what do they want to know? For 32, a sum of 2. How do I get a sum of 2? 1 plus 1. So how many times will I get a 1 and 1 out of 36 possibilities? I'll get 1 plus 1 one time. Number 34, different numbers on the 2 dice. Different numbers on the 2 dice. Okay, out of 36 possibilities, I'll get different numbers here, 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 and here. And can you see what's going to happen? I have 6 possibilities here, right? And how many possibilities here? After I get a 1 here, I want a different number, so there's 5 there. You follow that? So if I count 1, 2, 3, 4, 5, 10, 15, 20, 25, 30, that's going to be 30 out of 36, where I'll get different numbers on the 2 dice. Well, it says in my book to stop at problem 35.
That sounds good.
So I guess we will. I guess what that means is I think that I've given you enough material to give you a headache.